Good afternoon, grade 5. So for today, we will learn another thing in math. So I want you to look at this one. So for our aim for today, we will find the probability of events based on an experiment which gives us actual outcomes. Take note of the term experiment here because later on, I will explain how this experiment has something to do with probability. And how is it different from our previous topic about theoretical probability? Now, let me ask you, have you seen a dice before? Yes, so most of us can see dice when we are playing board games such as Snake and Ladders and Monopoly. Now, what are the numbers that we can see there on the dice? So we have 1, 2, 3, 4, 5, and 6. Very good. These are the numbers that we can see on the dice. What could be the chance or probability of getting number 2 on the dice? Take a look at the number. So as you can see, what is our possible outcome there? 6. 1, 2, 3, 4, 5, 6. The total number of outcome. How about the favorable outcome? What could it be? Remember, I asked you, what is the chance or probability of getting number 2 from this set of outcomes? As you can see, there's only one number 2 there. So the favorable outcome is 1. Looking at this given value, what could be our theoretical probability? Remember, in our previous lesson, theoretical probability can be expressed by following this formula. Number of favorable outcome over number of possible outcome. So using this formula, what could be the theoretical probability for this one? So it is 1 over 6. So the chance or probability of getting number 2 from the dice is 1/6 or 1 over 6. Can we get its lowest term? No, it's already our answer. There's no need for you to get its lowest term. Any question about this? Now this time, let us imagine when you roll a dice in actual life, will you think this particular probability can really happen? Of course not, because there are instances that when we roll a dice, we can get the same number after several trials, right? So therefore, this probability can be changed when we actually roll a dice in real life because we can get different results. Okay? Now, this time, we will conduct an experiment to show you another kind of probability. Are you ready for that? Okay. Now, take a look at this box. So, I have here several set of unit cubes. Varies with different colors. So, we have black. We also have pink. We have a blue unit cube. An orange unit cube. A yellow unit cube. Brown, red, and green. So, teacher will pick it without looking in the box. And let us see how many times each color will appear based on the number of times I will pick one particular unit cube from the box. So, let me put a table here on the board first. So, we have trial 1, trial 2, trial 3, trial 4, trial 5. So, on this first column, you can see the number of trials. So it refers to how many times will I pick a certain unit cube from the box without actually looking at it. And what will be the actual outcome? Meaning to say, even teacher doesn't have any idea what will I pick. Okay? So let's start with our experiment. Please take note of the actual outcome that we will get from picking from this box without actually looking. Are you ready, grade 5? Now let's start with our trial 1. Okay, from trial 1, light pick. What color is this? Pink. Okay, let me put it back here. So how about for trial 2? I have green. Okay, now let's try another one for trial number 3. So I have here red. Okay, now, how about for trial number 4? So I have green again. And let's have our last trial. What will I pick? Is it pink? Is it green, red, blue, or brown? Or orange? Let me see. It's another pink. Okay, now, take a look at our table on the board. So, as you can see, teacher tried to pick cubes, a unit cube for 5 trials. And this is actually the actual outcome after I pick a unit cube without actually looking from the box. So, as you can see, for trial 1, I have pink. For trial 2, I pick green unit cube. For trial 3, I pick a red unit cube. For trial 4, I pick green unit cube. And for trial 5, I pick a pink unit cube. Now, let's describe the probability of each colored unit cube here. Now, let's have the pink unit cube. Can you see the pink on our actual outcome? So, how many pink unit cubes are there? So, we have 1 and 2. So, we have 2. 2 as our actual outcome. Okay? But, how many trials did I use there while picking a unit cube from the box? How many times did I try it? It's 5. Okay? So, the probability of picking a pink unit cube on the actual experiment that we did is 2/5. Where did I get this 2/5 again? This 2 is based on the actual outcome, and the 5 at the bottom comes from the number of trials. Okay? So, this is the probability of getting the pink unit cube. Now, let's try another one. So, how about the color red? What is the probability of getting the color red from our experiment? Okay, so we have, as you can see, 1. So, 1 as the number of outcome. And how many number of trials do we have again? It's 5. So, this 1/5 is the probability of picking a red unit cube. So, 1, it is based on the actual outcome. As you can see on our table, there's only 1 red there. And this 5 is based on the number of trials that I did during the experiment. Okay, now, another example. How about color green unit cubes? Take a look at our table. How many times did color green appear? It's 2. Very good. How about how many trials did I use a while ago? How many times did I perform picking unit cube? It's 5. So again, the probability of picking a green unit cube from our experiment is 2/5. Okay? So now let me further explain what we did on this particular kind of probability. Remember, I keep on mentioning a while ago the term experiment. Okay, when you say experiment, like in science, you actually conducting it. You test something to get a result. Like what we did on our previous activity, I just simply pick a unit cube from the box without actually looking at it. So therefore, I don't have any idea what will I pick because I just simply looking somewhere else while picking a unit cube. And how many times did I do that? It's 5. So I conducted 5 trials for this experiment. So what we did a while ago is another form of probability. And that is based from the word experiment. What do you call that? That is what we call experimental probability. Okay, again, what do you call that? That is an experimental probability. From the word itself, experiment, we can get this from conducting a test, an experiment per se, to find the result. Okay, now let's further explain what this experimental probability is all about. Like what I said, this experimental probability came from the premise that the result just came from a certain experiment. That's how we can define the word experimental probability. It is based on the result of an experiment. That's why, from the name itself, experimental probability. Okay, it is just based on our experiment. The result per se on the experiment that we conducted. How can we write or express in its probability? Is it the same with our theoretical probability? No. You go back with how we express our experiments in probability a while ago. What have you observed? Remember, probability can be written in a form of fraction. So what should we put on top and what should we put at the bottom? Okay, on top, we put the number of outcome happen. Okay, it is the number of outcome happen on the experiment that we conducted, or the number of outcome and how many times it appear on our experiment. Take note that this one also refers to how many times it appear on our experiment. That's why if different people will conduct the same experiment a while ago, they may arrive with different results. Okay? Because since that's an experiment, we really don't know what will be the real outcome. It just depends on how many times it will appear, depending on the person and the experiment they conducted, depending on the result of that. Now, how about at the bottom? What should we put there? It is the number of trials. Okay? So again, number of outcome happen, or how many times it appear, over the number of trials. That's what an experimental probability can be expressed. Now, let's differentiate the two kinds of probability that we have so that you can easily identify if that is a theoretical probability or if it's just an experimental probability. Let me have a table here on the board. So we have experimental probability, and the other one, the one that we discussed yesterday, theoretical probability. Both of them are kinds of probability. They are both used to describe the probability or the chances or the likelihood of the event to happen. But what makes them differ? When you say experimental probability, from the word itself, it is based on the result of the experiments. Okay, that's why we have the actual outcome there, because it is based on the result of your experiments. That's why from the name itself, it's experimental. It is based on experiments. Now, on the other hand, theoretical means, or it is based on the premise that all events are actually likely to happen, or they are equally likely to happen. So meaning to say, all the events have an equal chances of occurring from the particular events. They are equally likely to one another. That's their chance in theoretical probability. However, on the experimental, it is just based on the result of your experiments. That's why people conducting the same experiments may be arrived in different results when it comes to experimental probability. But in theoretical probability, if there's a given, there should be a specific answer only, because we don't have to conduct experiments on theoretical probability. Is that clear? Another differences of these two kinds of probability is the formula that we can use in expressing this in numbers. Okay? Although both of them are in fraction form, however, we have to follow different formula for the two kinds of probability. Let's start off first with theoretical probability. What's the formula behind that? Number of favorable outcome over number of possible outcome. So that's the formula that you have to follow in expressing theoretical probability. Favorable outcome over possible outcome. The event that you wish to happen over the total number of events given. Okay. On the other hand, when we are talking about experimental probability like what we did a while ago, it is based on the formula, the number of outcome happen, or how many times the event occur in a particular experiment. How many times will it appear over the number of trials that you have or conducted. Again, when you say experimental probability, it is derived from the formula the number of outcome happen over the number of trials, or simply the number of times the event appears over the number of trials that you have. Take a look with this diagram and see the differences between experimental and theoretical probability. Take note that these two, when you express them, it should be in fraction form. That's why, if it's needed, you have to get the lowest term of that fraction. However, they are different in terms that you have to follow different formula in expressing them. Let me repeat it one more time. When it's an experimental probability, since it's based on your experiments, the formula that you have to follow is number of outcome happen, or how many times the event appears on the experiment over the number of trials. And on the other hand, when you say theoretical, since it is just based on the premise that the events have an equally likely chances to happen, it follows a formula of number of favorable outcome over the number of possible outcome. Now, let me give you an example problem. So, let me write it first. Okay, so Ryan chose breakfast for a week. So here are his choices. So we have milk toast. We also have fried rice. We have chocolate pie. We have here ham and egg. And the other one is a French bread. So here are the choices that Ryan made for his breakfast for the week. So we have milk toast, fried rice, chocolate pie, ham and egg, and French bread. Now, what is the theoretical probability of picking a milk toast from his choices of breakfast? Take a look. Okay, so it's 1/5. Why it's 1/5? How many possible outcomes do we have? Okay, we have 5. Very good. And how many times we can pick milk toast from the choices? Only 1. Very good. Because that's the number of favorable outcome that we have. So the theoretical probability for this one is 1/5. It is derived from the formula the number of favorable outcome over the number of possible outcome. Now, what if different scenario happen in choosing his breakfast? What if Ryan put the words or the food rather on the cards and he conducted an experiment by picking what card will he eat for breakfast? Okay, so let's have for day 1, he picked milk toast. For day 2, he picked ham and egg. For day 3, he picked milk toast again. For day 4, he picked milk toast for the 3rd time. And for day 5, he picked fried rice. Now, what could be the experimental probability of picking milk toast after Ryan conducted an experiment? Okay, so it's 3/5. Very good. Why it's 3/5? Because based on the experiment he conducted while picking a card with food written on it, he picked milk toast 3 times. So 1, 2, and 3. Meaning to say, the card with a milk toast on it is picked for 3 times. Or the card with milk toast appears thrice. Okay? And the number of trials that Ryan did for the experiment is 5. So it's 3/5. So let's go back with the theoretical probability a while ago involving Ryan's choice of breakfast. So the theoretical probability is 1/5 and the experimental probability of picking a milk toast is 3/5. So which is greater? Is it the theoretical probability or the experimental probability of picking milk toast as his breakfast choice? So 3/5 is greater than 1/5. So therefore, upon looking at this data, the experimental probability is greater than theoretical probability of expressing how many times a milk toast can be picked from his choice of breakfast. Okay? So can you see the difference now between the experimental probability and theoretical probability. So, let me recap that for one last time. So, when you say theoretical probability, what's the formula behind that? Number of favorable outcome over number of possible outcome. Take note that you have to follow this when you will be asked to get the theoretical probability. Number of favorable outcome over number of possible outcome, because it is just based on the premise that all events are equally likely to happen. And if you will be asked to get the experimental probability, you have to follow the formula number of outcome happen, or how many times will appear in our experiment, over the number of trials that you did. Okay? So this experimental probability is based upon the result of your experiments. That's why from its name, it's experimental, because it is just an experiment in nature. So I hope you learn the difference between the two kinds of probability from our today's lesson in math.